Have you ever stopped to think about what's really keeping the lights on in a huge skyscraper, or what's powering those giant machines in a factory? Well, the answer is often hiding in plain sight. It's a component most people have never even heard of, but it's basically the hidden superhighway for all that electricity. We're talking about the busbar.
And nope, I don't mean the regular old wires you got running through your walls. This is something else entirely. This is the heavy-duty industrial-grade backbone that's built to handle enough power to run a small city.
So this is it, the busbar. I love the analogy of a superhighway for electricity because it's perfect. A normal wire, that's kind of like a quiet side street. A busbar, though, that's the 8-lane interstate, channeling massive currents right through the heart of our electrical systems.
But here's where it gets crazy. When you're making these things, the margin for error is basically zero. We're talking about a flaw thinner than a single piece of paper being the difference between everything running smoothly and, well, a catastrophic failure. So how on earth do you manufacture something so critical with that level of perfection?
Well, to solve a problem that big, you can't just tweak the old ways of doing things. You need a full-on revolution. And for busbars, that revolution was metal stamping.
And seriously, the difference is like night and day. On one side, you have the old school way. It's slow, it's not very accurate, and the quality totally depends on how skilled the operator is that day. But on the other side, you've got metal stamping. We're talking insane precision, lightning-fast speed for high volumes, and perfect, repeatable quality every single time. It was a total game changer.
And you know, this isn't just about making things faster. Stamping is what makes it possible to mass-produce parts that are absolutely identical and reliable. It's also designed to waste as little of that expensive copper as possible, which really drives down the cost. But the most important thing? It achieves that microscopic precision that is just non-negotiable for electrical safety.
So of course, engineers looked at this awesome process and said, okay, how about we make it even more efficient? And what they came up with was a way to basically cram an entire assembly line into one single machine.
It's called progressive die stamping. Just try to picture this. You've got this whole assembly line, right? But it's all happening inside one powerful machine. A long strip of metal feeds in one side, and with a single stroke of the press, it goes through a whole series of different shaping steps, and out the other end pops a perfectly finished busbar. It's incredible.
Let's walk through it real quick. It's like a perfectly choreographed dance of metal and machine. First, the strip feeds in, then, bam, holes get punched through. Next, little sections are notched out from the sides. After that, it gets bent into the exact shape it needs to be. And finally, the finished part is blanked, which is just a fancy word for cut, from the rest of the strip. And all of this happens in the blink of an eye.
Okay, so making the basic shape is one thing, but the final steps, the bending and the punching, that's where this whole quest for absolute perfection really gets intense. You know, the source material for this explainer put it perfectly. Precision is not merely a quality metric, it is a safety requirement. That really hits the nail on the head. We're not just trying to make a part that looks good, we're trying to prevent fires and system failures. It's all about safety.
So, just how precise are we talking? Well, get this. The thickness of the busbar itself can't be off by more than 0.05 of a millimeter. To put that in perspective, a single human hair is thicker than that entire margin of error. Wow.
And it doesn't stop there. The position of every single bolt hole has to be accurate to within 1/10 of a millimeter. If it's off by just a tiny bit, the connection won't be totally secure, and that, my friends, can lead to some very big problems.
And finally, the angle of every single bend. That has to be perfect to within 1/2 of a single degree. That is just an almost unbelievable amount of control over a solid piece of metal.
So why this obsession with these tiny numbers? Well, it all comes down to this. This level of accuracy guarantees that the busbar fits perfectly, that every connection is rock solid, and most importantly, that you prevent dangerous heat from building up, which is the #1 enemy of any electrical system.
And, you know, getting this right isn't a one-size-fits-all kind of deal. Manufacturers have a whole garage full of specialized machines. You'd use a simple manual bender for a quick prototype, but for a super complex 3D busbar that looks more like a metal sculpture, you're going to need a much more advanced machine. It's all about picking the perfect tool for that specific job.
So, what's the next logical step in this evolution? I mean, what happens when you take all these super precise, separate steps and bring them all together? Well, you get the future of busbar manufacturing, a completely integrated, all-in-one solution.
And here it is. Meet the 3-in-1 busbar processing machine. This thing is literally the Swiss Army knife of the industry.
It takes the three main jobs, cutting, punching, and bending, and rolls them all into one seamless workflow on a single machine.
And the benefits are just enormous. Since the part never leaves the machine, you get rid of those tiny little errors that can happen when you move it around. You cut down on human mistakes, you save a ton of space on the factory floor, and your productivity goes through the roof. It really is the peak of manufacturing efficiency.
And this kind of efficiency couldn't be arriving at a better time. Right now, the big demand is coming from renewable energy, like wind and solar farms. But just around the corner, the explosion of electric vehicles and giant battery storage systems is going to demand busbars that can handle even more power. And if we look further out, things like AI-powered inspection and 3D-printed tools are set to change the game all over again.
So we've seen how this incredible precision manufacturing built the backbone of the electrical world we live in today. But as our world gets hungrier and hungrier for more power and more efficiency, it leaves us with one heck of a question. What new, almost unimaginable level of precision will we need to invent to build the electrical superhighways of tomorrow?